In this video, we're going to continue reviewing for the Chapter 5 tests on polynomials. Now, and this is going to review topic 5.3, where we learned about the degrees of graphs. We learned that the degree is even when they're facing same directions, so ends face same direction, and it's odd when the ends face opposite directions. So if you look at the first graph here, these ends are facing opposite. So this is an odd degree function. In the second graph, these ends are facing the same direction. So since they're the same direction, this is an even degree function. In 5.4, sorry, this was over 5.4 as well. So in 5.4, we also learned about end behavior. Let me fix how this looks. So this should say as x approaches infinity, y approaches blank. As x approaches negative infinity, y approaches blank. So here when it says as x approaches positive infinity, you want to look at where your x's are positive. Your x's are positive on the right side of the graph. So you're going to look at your right side of graph and see what's happening at the end. That's why it's called end behavior. So on the right side of the graph, my graph is going down. Since it's going down, that means y approaches negative infinity. On this next graph, they want to know what happens as x approaches negative infinity. So your x's are negative on the right side of the graph, or sorry, on the left side. So for this one, we're looking at our left side. And we're looking at that end. So that end's actually going up. So since it's going up, y is approaching positive infinity, or just infinity. So when they're talking about x, they're telling you what side to look at. If x is approaching negative infinity, well, your x-axis is negative on the left, so you look at the left side of the graph. If x is approaching positive infinity, your x-axis is positive on the right, so you look at the right side of the graph. And for y, you're looking at that end and seeing if it's going up or down. Up would be positive infinity, down would be negative infinity. In 5.4, we also learned about max and min. So here, they want to know the relative minima. Minima are your low points. And we're going to identify the x-coordinates where they occur. So I see a low point here at about negative 0.5. And I see another low point here at about 3. So these happen at negative 0.5 and 3. And then relative maxima, was plural for maximum, would be your high points. Let me do that one in another color. So on the graph, I see a high point right here at 2. And another high point here at about 3.5. So minima are low points, maxima are your high points. Something else that we learned about in this topic that I don't think I included in these slides are our zeros. So your zeros are your x-intercepts. So I could ask like how many zeros are there. So this graph, for example, has 1, 2, 3 zeros. One of them's at about x equals negative 1.5, the other one's at about 1, and the other one's at about 4. In topic 5.4, we discussed factoring. So here we're going to factor these expressions. You always want to look for a GCF first, or a greatest common factor, something that all the terms can be divided by. So here in this first problem, I notice all of these can be divided by 3. So I'm going to factor out a 3. They don't have a letter in common, so I'm only factoring out the 3. So this is going to become n squared minus 4n minus 12. And now I notice that inside the parentheses I have a trinomial. So I'm going to factor using my blank method. For 12, you could do 1 and 12, 2 and 6, or 3 and 4. If you want 4, or negative 4, you would actually do 2 minus 6. So this parentheses I can separate into 2 new factors. Both are going to start with n, because n times n will give us that n squared. And then I'll put the positive 2 and the negative 6. The 3 that we had already factored out needs to be included, because that's one of the factors for this problem. Question 2, we're going to start by looking for a GCF. I notice both of these can be divided by 4, so I'm going to factor out a 4. They both also have an x. I like to use the one with a smaller exponent because they need to both be divisible by it. So I'm going to factor out an x as well. And they also both have a y. You notice we have y cubed and y squared. You would factor out the y cubed because both of them can be divided by that. Remember, when you're dividing, you're going to subtract exponents. So 8 divided by 4 is 2. Here, 1 minus 1 is 0. These cancel. And 3 minus 3 is 0, so these cancel. Then 20 divided by 4 is 5. 5 minus 1 would be x to the 4th. And 6 minus 3 would be y to the 3rd. So these would be my factors. The parentheses that's on the inside, we can't factor anymore because there's no common factors there, and it's not a difference of squares. In the final topic, 5.5, we learned how to solve using factors. So here on the first one, we're going to solve by factoring. So you always want to look for a GCF first. Here I notice, even though all of these don't have a number, they all have a b. So I'm going to factor out a b. When I do that, this becomes b squared minus 8b plus 12. Inside, I have a trinomial. So I can factor using the blank method. For 12, you can do 1 and 12, 2 and 6, or 3 and 4. To get 8, you would want to add 2 and 6. But since it's negative 8, both of them have to be negative. So this can be split into 2 new factors. I'm going to put b and b because b times b is b squared. And then we can put the negative 2 and the negative 6. The b that we factored out at the beginning goes out in front. These are done being factored because there's no exponents anymore. So now you just set each of them equal to 0 and solve for b. Here we will do plus 2, so our answer is 2. Here we do plus 6, so our answer is 6. So our solutions for b are 0, 2, and 6. On question 2, I'm going to start the same way. Look for a GCF. I notice both of these have an x. So I want to take the one with the lower exponent, which is the x squared, and factor that out. X to the 4th divided by x squared is x squared. And then here the x squareds cancel. Now I'm going to look inside this parenthesis, see if I can factor it more. It's a binomial. So I can do a difference of squares since it's a subtraction problem. Here I notice this is x squared. Then minus 25 is actually 5 squared. So since it's a difference of squares, I can write it as 2 factors. Both of them are going to have the x and the 5. It's just one will be plus 5, one will be minus 5. And that x squared that we factored out at the beginning goes out in front. Now that we have all our factors, we're going to set them each equal to 0 and solve for x. The opposite of x squared would be to square root. So x would equal positive or negative square root of 0 or just 0. There's no such thing as positive or negative 0, so this one's just 0. Here if you do minus 5, your solution is negative 5. And on the last one, we would do plus 5. So our solution is positive 5. So this one had 3 answers, 0, negative 5, and 5. So this concludes our Chapter 5 test review. You can use these videos to help you. You can also use the notes that I uploaded if you already get the hang of it and you just want to look over for a refresher.